Okay, good morning, good afternoon. Today we're going to be talking, on the last lesson we talked about two-dimensional figures, and then today we're going to talk about three-dimensional figures, all right? Specifically, a lot of stuff about polyhedron, okay? Polyhedron's a big word for a very simple concept. A polyhedron is a three-dimensional figure that's made up of polygons. So if you go back to the lesson from yesterday about polygons, all the sides are polygons, okay? So, yeah, polyhedrons, that's a polygon, all the sides are made up of polygons, so it's a polyhedron, okay? Non-polyhedron are not made up. A cylinder is not a polyhedron because the base is a circle, right? The base is a circle. A sphere is not a polyhedron either. Now, what's interesting about them, non-polyhedral shapes, is that the math that you end up doing, because we're going to spend a lot of time on this lesson about surface area and volume. I'm going to break it up into two pieces today. I'm going to do one piece on surface area and then one piece on volume. So we're going to do these two lessons separately. But what's interesting is a lot of the rules that the non-polyhedron follow are exactly the same as the polyhedron. Because what you can do is you can think of a circle as a polygon that has an infinite amount of sides, right? And the sides are so small that it looks like a curve. So, in fact, if that makes sense, right? The more sides you put on something, the closer it starts looking like a circle, right? If you have more sides, the closer it is to the circle. So if you had really small sides, it would start looking like a circle, right? So a lot of the rules that polyhedrons follow are the same as the non-polyhedron, okay? Because you can think of non-polyhedron as like a shape with like an infinite amount of sides, okay? All right, so the first thing is we need to talk about, some people call them Euler's formula or Euler's formula. I think the correct name is Euler, but I usually call it Euler because I've been saying it for so long, okay? What Euler's formula says is this is a fact of all polyhedron. The number of faces it has plus the number of vertices that it has. I just have this weird feeling that I'm not recording. Oh, I am recording. Am I recording? Yes, I am. All right. What Euler's formula says is the number of faces that something has plus the number of vertices always equals the number of edges plus 2, which is really neat, right? If you take a shape that we already know, let's take a cube, right? And we figure out how many faces, how many vertices, and how many edges it has, right? Well, a cube has 6 faces. The vertices it has, we can count them, right? 1, 2, 3, 4. 4 on the back, right? 4 more on the back, right? So that's 8. And then 1, 2, 3, 4 on the side. So that's 4 times 3 is 12. So it has 12. Oh, dang it, I put that in the vertices. It has 12 edges. And then how many vertices does it have? Well, I'll do that in blue, let's say, right? So it has 1, 2, 3, 4 vertices, and then 4 more on the bottom, right? So 8. Now look what happens. 6 faces plus 8 vertices always equals the number of edges plus 2. 6 plus 8 is 14, and 12 plus 2 is 14. 14 equals 14. So Euler's formula is actually a nice way to check things. If you want to know how many faces, vertices, and edges something has, if Euler's formula doesn't work, you know it's not right. And the way I memorize Euler's formula is faces plus vertices equals edges plus 2. I like to remind myself by saying the number 52. Look, can you kind of see the word 5? 5, 2? 52. That's how I memorized it, 52. Faces plus vertices equals edges plus 2. Okay? So use Euler's formula to verify that things are right. Because if Euler's formula doesn't work, then you know you messed up something. Okay? Okay, so the first thing we're going to talk about today is volumes. And then I'm going to do a separate lesson tomorrow on surface areas, okay? So let's talk about polyhedron first, okay? Let's look at prisms first. So this is a prism, right? I can do a pentagonal prism, right? I can even do a cylinder, which is prism-like, right? All right, so the first thing we need to know, these are prisms, right? prisms have two bases, okay? So we can call this the base, and then the bottom is also a base, right? If I can draw it in, that's a base. Prisms always have two bases. Now, how do I find the bases? I wish you were in my, if we were in my class, I could show you with all the shapes I have all over my room, but we're not in my class. But the way you decide where the bases are is the bases are the two sides that are congruent, so they're equal, and they're parallel to each other. So in this shape right here, this side in red, and this side back here that we can't see, right? This one that we see back here, right? We can't see it. Those two are the bases. So this is the base, and on the back there's another base. Okay? So those are the bases. So where's the bases of a cylinder? The bases are here and then at the bottom, there. Now, rectangular prisms are interesting because anything can be the base. Because remember the rule for bases. The bases have to be this congruent to each other and they have to be parallel. Well, check this out. Do this in yellow. This side right here in yellow is parallel to the bottom and they're congruent. So those could be the bases. But this side, right? This side right here and the back side are also congruent and parallel. So they could be the bases. So in rectangular prisms, they have to tell you where the bases are. Okay? That's the only one that's true for that. Okay, so we first have to know where the bases are. All right? If I looked at a pyramid, if I drew a couple pyramids, right? I'll draw a square pyramid. I'll draw a hexagonal pyramid. Right? Something like that. And then let's say a cone even, right? Something like that, right? What you'll notice is prisms have two bases, but pyramids have one. And they're much easier to identify. This is the base of this pyramid. This is the base of this pyramid. This is the base of the cone, right? So they have one base. Pyramids have one base. Prisms have two bases. Okay? All right. That's some basic understanding. All right, the second thing, let's talk about those bases. Let me draw a couple more prisms again, all right? Actually, I'll just do a... Let's do this one. That's a prism, and then I can also do a triangular prism, right? That's a really poorly drawn picture. Let me fix this one. Yeah, like that, right? All right. Okay, so these two, the bottom ones in red are prisms, the top ones are pyramids. Okay, so these are the base, right? Base, and on the back is another base. Here's the base, and on the back is another base, right? That's the bases. Now, so the bases are easy to identify in prisms because they're congruent and they're parallel. In a pyramid, it's real easy. The base is usually what it sits on. I'll tell you right now, prisms usually don't sit on their base. Prisms usually sit on one of their sides, but not their bases, okay? Every once in a while, that's the case. Pyramids usually sit on their bases, right? So this is the base of this pyramid, right? Base of the triangular, or the square pyramid, pentagonal pyramid, and the cone, right? Those are the bases. Now, the question is, where's the height? I'm going to do this in blue. The height in a pyramid is straight from the top, straight down to the middle of the shape. That's the height. From the top, straight down to the middle of the shape. That's the height. From the top, straight down to the middle of the base, right? That's the height. Now, where's the height in a prism? The height is the distance between the bases. So it kind of, if we were in my class, I'd do this with my hands, right? Put your hand here and put your hand here, right? So touch the two bases. The distance between your hands is the height. That's the height. The distance between your hands is the height. So it's the distance between the two bases, right? If you put your hands on the two bases, the distance between your hands would be the height. So that's how you find the area, the base and the height, okay? All right, we need that because we're going to talk about prisms real quick. Let's talk about a real simple one. Let's do a triangular prism. Something like this. And let's say this is 3, this is 4, and this is, we'll say, 10. Okay? And let's call this 5, because that'd be a 3, 4, 5 triangle. Okay? If I ask you to find the volume of this prism, you will learn very quickly that the volume is equal to big B times H. Okay, so big B, let's talk about big B. When you see capital letters in formulas, that usually means that work needs to be done. Work to be done. If it's lowercase letters, it's usually just a number. But if you see a capital letter, it usually means it's not a number, it's usually you have to calculate something. And big B stands for area of the base. The formula for volume is big BH. You'll never hear me say BH, you hear me say big BH. Big B means the area of the base times the height. Okay, so where's the base? Remember what we said earlier. The bases are the two sides that are parallel and congruent. So this is the base, and the back would be the base, right? The one that's over here, like that, yeah? That's the base. So the first thing we have to do is find the area of the base, right? Well, what shapes the base? A triangle. So we have to find the area of the triangle. Oh, well, area of the triangle is base times height divided by 2. We learned that yesterday, right? So the base is 4 times 3 divided by 2. Because remember, we're just looking at the triangle right now. This is 3, right? And this is 3, this was 4. We need to find the area. So the area of the base is 4 times 3 over 2, which is 6. So the area of the base is 6, right? And then the height is the distance between the bases, which is 10. So if we were to solve this, we would do the area of the base is 6, the distance between the bases, which is called the height, is 10. So the area is 60. All right, let's do it again with another shape. So let's do a square prism. And remember what I said in, let's do a rectangular prism. I said a square prism, but I meant a rectangular. It's badly drawn, right? I gotta fix this. I'm a decent drawer, so I gotta make sure it looks good. Holy cow, that's bad. All right, so it looks something like this, right? Okay, so let's call these the bases. This is the base, and the back is the base, right? Remember the volume formula. Volume equals big B times H. Big B is the area of the base, right? And this is the height. The height, the distance between the bases, okay? All right, so we got to find, so let's say this is 3, 3, and 20, okay? So we first have to find the area of the base. Well, what shape is the base? It's a square. So we're going to do 3 times 3, or 3 squared, times, what's the height? The distance between the bases is 20, all right? So you get 9 times 20, which is 180. So the volume is 180. And incidentally, if these were in centimeters, right? If these were all in centimeters, this would be centimeters cubed. Let's talk about what a centimeter cubed is, all right? If I say something is 3 centimeters cubed, I don't mean that it's a cube that is 3 by 3 by 3. That is incorrect. It's a very common misconception. It doesn't mean it's 3 by 3 by 3. What this means is you have 3 1 centimeter cubed cubes. Okay, that sounds kind of weird. What it means is you have 3 cubes. What kind of cube? A centimeter cubed. Well, what's a centimeter cubed? It's 1 centimeter by 1 centimeter by 1 centimeter. So when you see 3 centimeters cubed, you're really seeing 3 1 centimeter cubes, right? You're really seeing 3 cubes that are all 1 by 1 by 1. That's what centimeters cubed is. So if somebody says something is 180 centimeters cubed, it does not mean that the sides are 180. No, that is incorrect. What it means is you have 180 of these little cubes, these 1 by 1 by 1 cubes. It takes 180 of those cubes to fill up the shape. That's what a centimeter cubed is. Okay? All right. So let's go to our notes real quick. So notice we have volume. Volume is big BH. So let's do. I guess I'll talk about the pyramids real quick first, and then I'll go to these notes. Okay. Pay attention to what I'm about to say. Okay, this is important. If I have a square prism, okay. I really wish we were in class right now so I could talk to you about this. If I have a square prism, and let's call this the base, okay? So this part down here is the base. So that makes this the base too, right? Which would make this the height. All right. What you need to understand, we already know the volume of the prism is big BH. We just learned that, right? If inside of that shape I drew a pyramid that goes to the top of that shape, right? So it goes to the top of that shape, right down to the middle, right there, yes? And I ask you to find the volume of that. What is the volume of that pyramid? Here's what you would realize if you started playing with it, okay? You would realize pretty quickly that the volume of the pyramid is the same as the volume of the prism, only it's 1/3 of it. What you're saying is you can fit 3 of these pyramids inside of that prism. That is the key. If you could find the volume of the prism, then you know that the volume of the pyramid would be 1/3 of that. So look what I'm saying here. If I drew a triangular prism, right? Right? And I found the volume of it. And I found the volume of the prism was, let's say, 60. Okay? And then I ask you to find the same volume of a pyramid. And so I'll draw the pyramid inside of there. So what if I said find the volume of this pyramid instead? The volume of the pyramid would be 20 because it'd be 1/3 of that. Three of these volumes can fit inside of the 3 of the volumes of the pyramid can fit inside of the prism. Okay? All right. I might skip around a little bit. Yeah, I'm going to skip around. Let's do this one first. Let's find the volume of this prism, right? Well, remember on rectangular prisms, any 2 sides could be the base. So I'm just going to say this sides are the base, right? This is the base, and this is the base. So the volume of a prism is big B times H, right? Big B, remember, big B stands for area of the base. So how do I find the area of the base? Well, the base is a rectangle, so you're going to find 6 times 5.2 times, what's the distance between the bases? The distance between the bases is from here to here, so it's 10. So all you're going to do is multiply that out, right? So 6 times 5.2 times 10. 312. The volume is 312 centimeters cubed. Okay? Let's do letter D. Let's first find the volume, right? Volume is big BH, so I have to know where the base is. But remember, the bases are parallel to each other and the same. So this must be the base, and the back side must be the base. Right? So we got to find the volume of the triangular prism. So we first had to find the area of the base. Well, let's look at this real quick. Right? It's like this. I need to find the area of that shape. I don't need the 5, do I? Because remember, base and height. So 3 times 4 over 2. Right? Times. H is the distance between the bases. Right? The distance between the bases is right here. I'm going to do this in blue so you can see it. Right? This is the distance between the bases. Oh, 5. So we get 3 times 4 over 2, which is 6. 6 times 5 is 30. 30 meters cubed. All right. Let's look at a cylinder. Now here's the cool thing about a cylinder. We know that the volume of a prism is big BH. But what we can do is we can think of a cylinder as like a circle, right? The circle could just be considered a base that has an infinite amount of sides. You don't need a new formula for it. Look, cylinder gives you this formula, okay? And I'll talk about this formula in a minute. But it's actually just this formula. These two formulas are the same, and I'll show you in a minute. Because I can think of a cylinder like a prism, I can use the same formula, right? So I first have to identify the base. Well, that's easy. In a cylinder, the base is that, and the base is that, the circles, right? So I first have to find the area of that circle, right? Well, how do I find the area of the circle? Oh, pi r squared, right? So pi times 6 squared, right? The area of the base of a cylinder is pi r squared because the base is a circle and the area of a circle is pi r squared. So you end up with pi r squared h. So let's go back up here and look at this. This piece right here, I don't want to get the, I wish I can zoom in. Can I zoom in? Yeah, there we go. All right, this piece right here is the area of the base. So that piece right there is the same as this b. Pi r squared is the area of a circle, so that's the area of the base times the height. Notice now that these two formulas are basically the same thing, right? This formula here and this formula here are the same thing. All right, so going back here, yes? Zoom in again. Okay, so I'm finding the area of the base, which is pi r squared, right? Which is what, 36 pi, right? And if I want to find the volume, so that's 36 pi times how far between the bases? 18, right? The distance between the bases is 18. So I'm just going to do 36 times 18 times pi. I'm just going to leave it in pi units. 36 is 648 pi units, right? Really, it'd be feet cubed. All right, let's do the pyramid. Remember what I said about pyramids. If you were to sketch out the prism that went with that pyramid, right? And it would look something like this, right? Looks better than that. Let's see, look at this. Right, so it looks something like this, right? That's going to the middle, right? Remember that the volume of the pyramid is 1/3 of the volume of the prism. So the volume of the pyramid is 1/3 big BH. Where's the base? The base is right here. This is the base. So the volume is 1/3 of the area of the base. Well, I don't think they tell us, but that's also 6. So we've got to find the area of the base, which is 6 times 6 times the height. The height is the distance from the top of the pyramid, right, straight down. Oh, that's the 4. So we're going to do 36 divided by 3, which is 12, times 4, which is 48. Okay? Just remember, think of it like a prism and just do 1/3 of it. Don't forget about the 1/3. All right, we're going to add a couple more shapes here. So let's do letter E and F and G and H, and then we're done, okay? You know what, I'm not going to do, I'll just go through E very quickly. Volume, the prism, is big BH. So let's call this the base, right? So how do I find the volume? Well, I find the area of the base, which is 3 squared, right, because it's a square. How far is the height? The height is the distance between the two bases, so it's 4. So this is 9 times 4, so this is 36 centimeters cubed. All right, we've got to talk about the next one, the sphere. The sphere has its own formula. You just have to memorize it. Volume is 4/3 pi r cubed. 4/3 pi r cubed. volume is 4/3 pi r cubed. You don't have to memorize that. I'll give you formula charts, right? So 4/3 pi, what's the radius? 6 cubed, right? So we get 4/3 times pi times 216. And then just do the math for that. 4 divided by 3 times 216 is 288 pi. 288? 288 pi. And it would be inches cubed, right? So volume of spheres are easy. It's just that formula, okay? All right, next one. All right, let's find the volume of this pyramid. Volume of a pyramid is 1/3 big BH. 1/3. This is the base. So we got to find the area of the base. It's a circle, so it's pi r squared, right? So it's 1/3 pi r squared times h. So it's 1/3 of pi times, what's the radius? 2 squared. What's the height? Remember, the height is the distance from the middle of the shape to the top, right? And I believe they give it, do they give it to us? No, I don't think they do. Check this out, this is the first time. We don't know what the height is yet. What we do have is we have this right here, don't we? Right? I'll tell you what, let's just make our life easier right now. No, we're gonna do it. So how do I find the height? It's a Pythagorean theorem question, right? We know that 2 squared plus 4 squared should equal the oops, sorry. Let's fix it. We know that, remember A, B, and C, right? We know that A squared plus B squared has to equal C squared. So we know that 2 squared plus H squared has to equal 4 squared. So we know that 4 plus H squared equals 16. So we know that H squared equals 12. So H is equal to the square root of 12. The square root of 12 is 2 times 2 times 3. So the height is actually 2 root 3. So the height is 2 root 3. Okay, so I can plug that in there. So sometimes you're gonna, in cones, they're gonna hide Pythagorean theorem from you. So be ready for that, okay? So this is 2 root 3. So what do we get? This one we're just gonna approximate. So I'm just gonna approximate, okay? So we get 1 divided by 3 times 2 squared is 4 times 2 times 3 root equals 4.6. Let's just call it 4.65. And if they wanted to, you could multiply by 3.14 to get that, yeah? Let's see, 4 times 2 times 2 is 4 times 2 is 8. Yeah, that's going to be about right. All right. Okay, the math is pretty easy. Just remember that for cones, you can still use 1/3 big BH. All right, last problem. Let's do this one. Okay, so it's a pyramid. So volume is 1/3 big BH. So the volume is 1/3 the area of the base. This is the base, right? This is B. What shape is the base? It's a square, so it's 15 squared. How tall is it? It's the distance from here to here. Right? Well, I don't know that, do I? I don't know what that number is. They don't tell me it. But here's what they do tell me. Check this out. See this triangle? They're hiding it from you. If the distance across is 15, then this distance must be half of that, which is 7.5. So in fact, we have this triangle that we're looking at, and we need to find out what the height is, but we know this is 7.5, and we know this is 17. So we could use Pythagorean theorem, right? We could say a squared plus b squared equals c squared. So we could say 7.5 squared plus h squared is equal to 17 squared. And then we could just do the algebra for that, right? Let's see, 7.5 squared, 56.25, plus h squared is equal to 289, yeah? Because that's what 17 squared is. Subtract the minus 289. So we get, wait, what just happened? Let's try that again. 289 minus 56.25 equals, there we go. H squared is equal to 232.75. 232.75. Square rooted. You get the square root of 232.75. I don't know what that is. We'll just square root that. What is that? About 15.3, right? The height is about 15.3. So that means this distance is about 15.3. What did I do there? I used Pythagorean theorem to find the height, right? Because they like to hide it sometimes. All right, so now we got what we need to know. So we now know the height of the pyramid. It's 15.3. And we can just multiply that out, right? So we got 15.3 times 15 squared times, if I want to do 1/3, I'll just divide by 3. Divided by, I just did times 0. Bad idea. Oh, I can't go back. Dang it. I have to start over. Okay. 1 divided by 3 times 15 squared times 15.3. About 1,147.5 meters cubed. Okay? All right. Don't let the math get in the way of the concept, because if you get the concept down, the rest is easy. So don't lose it. Don't lose the information here, okay? Volume of a prism, big BH. Volume of a pyramid, 1/3 big BH. Volume of a cylinder is pi r squared h, or big BH. Volume of a cone is 1/3 pi r squared h, or 1/3 big BH. And volume of a sphere is 4/3 pi r cubed. All right? So there you go. Those are the formulas for volume. Tomorrow I'll teach you how to do surface area. But good luck with that, and have a good day.